Good morning, everyone. My name is Petrakis. I'm a geographer with the Western Geographic Science Center of the U.S. Geological Survey in Tucson, Arizona. And today I'm presenting on mapping perceived social values of riparian ecosystems, the case study in Southeastern Arizona. For a quick presentation overview, first, what is a restoration economy? This is one of the terms that themes throughout the presentation and research that's very important. So I want to start out by defining this term and how we considered it. I'll then talk about its application within a riparian system, and then provide a quick overview of the Sonoyta Creek watershed, which is our study site. Number two, how can we identify areas for restoration? We use the Social Values for Ecosystem Services model, or SOLVS. SOLVS uses a collection of social survey responses, so I'll quickly provide a quick characterization of the survey respondents, what are their interests, what are their concerns, and so on. And then I'll talk about some of the results for selected social values from the SOLVS model. And then finally, how can these results close the research practitioner gap? How can they inform our respondent-defined restoration economy? And what are some of the implications for riparian areas in general, within the watershed and also beyond? So what is a restoration economy? This is a definition that we sort of put together through different sources, different readings, different projects, and ultimately we came up with this. A restoration economy is the process of improving ecosystem health by returning damaged or degraded ecosystems to the original state through activities or investments in the landscape, resulting in economic return. So in short, restoration through investment resulting in economic return. And there are many ways that this can be quantified or measured or even visualized on the landscape. And one of these ways is through ecosystem services models, such as SOLVS, which is what we used in our analysis. For SOLVS, two main inputs go into the model: social survey responses and environmental variables. Ultimately, it produces social value hotspot maps. And these can be used to develop a restoration economy or inform restoration. In this case, the construction of a flood control structure that might be able to reduce the risk of flooding or increase water quality, water quantity, or even increase greenness or vegetation in the particular area that it was built in. So that's how sort of the idea of developing a restoration economy can be done through ecosystem services models. Our study site was the Sonoyta Creek watershed. It's located about 50 miles southeast of Tucson, has roughly a population of 1,000. There's several important recreational opportunities and biodiversity hotspots within the watershed. For example, let me pull up my laser pointer here. The Arizona Trail runs from the north and up through the east of the watershed. There's a collection of wildlife corridors that connect the Santa Rita Mountains to the northwest, to the Patagonia and Huachuca Mountains in the southeast through here. Several entities own and manage land within the watershed, including a collection of state and federal organizations. The Coronado National Forest owns about 60% of the watershed, and that's in green on the map. There's also the Arizona Game and Fish and Patagonia Lake State Park. There are a collection of private parcels located primarily along the lowlands of Sonoyta Creek through here. And then three main conservation-based organizations own and manage land within the watershed, including the Arizona Land and Water Trust, Borderlands Restoration Network, and Nature Conservancy. And they're identified by shades of blue in the map on the right. So just for a quick characterization of the riparian vegetation within this watershed, it's primarily isolated pockets of riparian forest. It's not so much like even the Santa Cruz or the San Pedro in the area, or even the Rio Grande or Gila riparian forest. Generally, it's isolated pockets, although there are some areas of continuous riparian forest, particularly southwest of the town of Patagonia, towards Patagonia Lake. The water flows are largely ephemeral. If you can see on the image on the top left, they generally follow or occur during large precipitation events during the monsoon season, or even during winter precipitation events. There is some perennial flow, again, particularly southwest where you have the continuous forests, as well as some other areas. And then groundwater is also a source of water within the watershed. Generally, the vegetation is broadleaf species: Fremont cottonwood, Gooding's willow, ash, sycamore, and so on. And it's home to truly amazing wildlife. It's a beautiful area down in southeastern Arizona. So we use the Social Values for Ecosystem Services model, or SOLVS. What SOLVS does is it quantifies the relative value of social value types across the study area, and it can potentially explain the geographic distribution and relative intensity of social values. It is developed by Ben Sherrouse, Darius Semmens, and Ken Bagstad of the USGS. On the image on the right, this is an application that was done by Ben Sherrouse and others in 2011 of SOLVS for the Pike and San Isabel National Forest in Colorado. And what you can see in the image on the right is an example of what sort of product SOLVS produces. So areas that are highlighted in red, such as in here and in here, that's where you have high aesthetic social value. Areas in blue would represent more lower aesthetic social value. So you can begin to see areas that are highly valued by the respondents to the survey. And you can also see how that relates to environmental variables that are considered within the model. So in this case, average elevation or average slope. And you see what sort of properties align with high social value. So these are sort of the results the SOLVES model produces. Three main inputs go into the SOLVES model. First is social survey responses. We're using a social survey data that was collected by the Borderlands Restoration Network in 2017. It also includes study points and social value points provided by the respondents and a collection of environmental variables, which go into SOLVES and produce the social value hotspot maps and data as shown on the right. So really the most important point, or the most important input for SOLVES, is the study survey points provided by the respondents. And what the respondents were asked to do was place a point within the watershed and then identify the social values that relate to that point. So areas that are important to them. So in this case, this respondent put a point at Temporal Road or along Temporal Gulch, where you have the Arizona Trail, and wrote F and B. So to them, this point relates to future value and biological diversity value. They also drew a point at Sonoyta Creek State Natural Area or Patagonia Lake and wrote L, S, and E to go along with F and B for life-sustaining value and economic value, as well as a few other points throughout the watershed that were important to them. This respondent took a slightly different approach. They drew circles around areas that were important to them, so it was a little more challenging to interpret. The protocol for this is that you draw a point at the center of the circle, and that's the point that they're trying to identify. So they also wrote all, which represents all 12 social values that were considered. So what we did is we placed a point right around here, and we wrote all. We listed all values. They drew circles around sort of this canyon area. This is along Temporal Road or Temporal Gulch, Solero Canyon, Flex Canyon, even the Patagonia Mountains down here and throughout. So in the end, we looked through all the different survey responses, and we ultimately came up with a master list of roughly 60 locations that we believe were identified by the respondents to the survey that were important to them, that offered social value. And they occurred throughout the watershed and different types of areas, including high elevation mountain peaks, the towns of Patagonia and Sonoyta, as well as some of the intermediate canyons and flow lines within the watershed. And what we immediately noticed was of these, about 40 of them, roughly 2/3 of them, align directly with flow lines. So this is really important because these areas are where you have the perennial flow or the monsoon flows that occur or the winter precipitation events. And there are also areas where you do have the actual presence of riparian vegetation, or at least the potential to have riparian vegetation in these areas. So immediately we sort of notice this pattern that they identify, the respondents identify flow line areas as being important to them. So just for a quick characterization of the respondents, what are their interests, what are their concerns? Generally, they're in favor of low disturbance land uses. This includes gathering forest products, land conservation, non-motorized recreation, and opposed to high disturbance land uses. So housing development, motorized recreation, and commercial mining. They're generally concerned about water quality and water scarcity. A majority of the respondents were highly concerned about those, but not so much flooding. A majority of the respondents were only slightly concerned to flooding, which is kind of interesting. And then if they're familiar with the term restoration economy, which a majority of the respondents were, but if they were familiar with the term, they were willing to donate more on average than those who were not. So they were informed on this sort of concept. Conservation was important to them, and they would donate more towards conservation and restoration within the watershed. So the other important input that goes into the SOLVES model is the collection of environmental variables, and we included 7 overall. The first 4 are based on this concept of distance to water. So the first variable is distance to water stream order level 4, and this is for Sonoyta Creek, the primary flow line within the watershed. The next level is distance to water stream order level 3, and these are the main tributaries that extend from Sonoyta Creek watershed, or I should say flow into Sonoyta Creek. And then you have stream order level 2, and finally at the highest elevations and the most minor tributaries, stream order level 1. We also included a digital elevation model, or DEM, and a slope raster. And finally, we included a 2009 land use land cover product developed by Miguel Villarreal and others for the larger Santa Cruz watershed. The Sonoyta Creek flows into the Santa Cruz River, which ultimately flows north into the Gila River. So overall, we included 7 environmental variables, including a multivariate distance to water layer. And the reason for this is how the landscape is used in general. The main highway runs along Sonoyta Creek. So the respondents or the population would engage with Sonoyta Creek initially and then extend outwards along the main tributaries and so on. So we thought that was an important way to approach this research. So the fun part here, diving into some of the results. And as you can see on the left, these are the results. So as I mentioned before, SOLVES produces these rasters or these images that show where social value is perceived to be the highest by the respondents to the survey. And you can see sort of this main pattern. You see this sort of like vein-like representation of high value. And what that lines up with is the flow lines. So the big takeaway here that really was immediately obvious to us is that high value is particularly identified along the flow lines. There are some differences, contrast to that in some ways, cultural, economic, and historical value. Much of the value is located along Patagonia Lake in the town of Patagonia. Historical value is a little bit different. There's some pockets, isolated pockets of higher value within different areas, but generally you see high value along the flow lines. That's sort of the big takeaway from us. So I want to quickly talk about 4 different social values that provide slightly different results and may relate more specifically to restoration. 2 that are focused more on the physical properties and the physical experiences that the respondents would have with the watershed, including biological diversity and recreational value. And 2 that relate more towards the emotional interaction the respondents would have with the watershed, including aesthetic value and life-sustaining value. So looking at biological diversity first, so it is defined, and as the respondents would consider it, as it is home to such biological diversity. And what we noticed is that generally, overall within the watershed, there was widespread lower value. So there was the presence of low value in the intermediate areas between the flow lines. And this was interesting because this was not always the case for a lot of these areas. This is where you have upland vegetation, grassland, savanna. It's very mesquite dominant sort of type of vegetation. Now, for thinking about restoration, okay, if restoration was focused on increasing biological diversity in areas that were important to the respondents, what are ways this could be done? Some examples could include increasing habitat or increasing species diversity. This could include increasing habitat for the southwestern willow flycatcher and other species like that, or focusing on the wildlife corridors that connect the mountain ranges within the watershed, those sorts of things. Now, looking at recreational value, so it was defined in the survey as because it provides a place for my favorite outdoor recreation activities. Generally, the highest value is along Sonoyta Creek and the main tributary. So we start to see this pattern that's consistent. Just to identify some areas, this is Flux Canyon. This is Harshaw Creek extending through here. San Rafael Valley Road, you have Red Rock Canyon, Patagonia Lake. This is Temporal Gulch and Arizona Trail, and some areas up through here. So the other pattern with recreational value, or the other identifiable thing that we saw, was that generally the highest value is located around 10 kilometers around the town of Patagonia, so in this area. So if restoration is focused on increasing recreational value, it might be more focused on creating greater accessibility and opportunities for recreation. So trails or areas that have surface water, such as Patagonia Lake, which is one of the few areas that has perennial water throughout the watershed, but is also highly valued, as you can see here. Looking at life-sustaining and aesthetic value, which sort of represent more of the emotional interaction with the watershed, the respondents look at life-sustaining value as because it has life-sustaining value through protecting and renewing clean air, soil, water, etc. So this was actually the highest valued social value in the survey. So it was the most important social value to the survey respondents in general. Similar pattern, pockets of high value are located along the main tributaries, particularly Flux Canyon, in this case, Harshaw Creek, Crown Ranch up here into the Santa Rita Mountains. If restoration is designed more about supporting life-sustaining value, it might focus more on increasing native vegetation or creating more erosion control structures, developing more upland vegetation with grasslands and shrubs. This can reduce erosion throughout the watershed and throughout the riparian areas. Looking at aesthetic value, defined as I enjoy the aesthetics, scenery, sights, sounds, smells, etc. within the watershed. This one was interesting because we noticed more widespread moderate values. That was not the case with a lot of the other social values. So in these areas southwest of Patagonia, along Flux Canyon and Solero Canyon, as well as up into the Santa Ritas around Mount Wrightson and along Harshaw Creek and Red Mountain in this area. If restoration is designed more around increasing aesthetic interaction or aesthetic sort of experience with the watershed, it might be focused more on clearing overgrown vegetation or planting more native flowering species. Things like this might increase the aesthetic experience within the watershed or within the riparian areas in particular. So what we ultimately wanted to do was quantify sort of the overall social value and see if riparian areas were truly more valued than areas within the watershed. So what we did is we summed value index for all 12 social values, for all areas, for all pixels and locations within the watershed, and sort of divided them into 5 main classes decided by this natural breaks between low and high value. And we took the mean value, and the mean value within the watershed is 9.4. So this would sort of sit within this low to moderate range of social value. Looking at the riparian areas, first at Sunway Creek, 200-meter buffer around the watershed there, so right through the center of the overall watershed. The mean value within that area was 21.9, so much higher. And then within the main tributaries extending beyond throughout all of them, the mean value within those areas was 24.2. So for both of these, they're much higher than the mean value within the watershed and almost into the moderate to high range of value overall social value. So overall, this really does identify riparian areas as being highly valued to the respondents of the survey, which was really interesting for us to see in the end. So I'll quickly end with this, some implications for riparian ecosystems. Overall, SOLV's results can provide a structure highlighting where to invest. A similar ecosystem services model known as Invest has been used effectively sort of within this decision-making process and provides context of ways this can be done. Next steps for these results would be to incorporate SOLV's outputs to help determine how and where to invest. And this can be done through both public and private partnerships. Examples that are occurring even actively within the watershed include building of flow control structures, planting native vegetation, developing overall habitat. So some of these areas would increase greenness, would reduce the risk of flooding, increase water quality, water quantity as well. So overall restoration of the watershed, focusing on the social values that were identified by the survey respondents. And then there's opportunities to educate the population to protect and conserve the land. As I mentioned when I was characterizing the survey respondents, if they were familiar with the term restoration economy, they were willing to donate more. So if you can begin to inform the overall population of the value of this sort of work, you might be able to develop a restoration economy in that way. Some important considerations. Point selection is pivotal in determining the results. The flow lines, that's where a lot of the points were placed by the survey respondents within the watersheds. And that's where you saw the highest value. So the environmental factors drive the results. Spatial scale of receipt point was also very important. As I mentioned, one of the respondents drew a circle around the entire Patagonia Mountains, and we had to take the center point of that. And that point had a particular environmental variable sort of traits. It had a particular elevation, particular range and slope, and so on. So that was very important, and that can impact the results. The environmental variable selection can be important. We used a multivariate distance to water layer. We thought that was more appropriate based on how the landscape is used. Ownership could have also been used as an environmental variable, and that may impact the results of the study. And then finally, a characterization of respondent population. Was there a sample bias? Generally the overall respondents were very much engaged in conservation and restoration within the watershed. We looked at demographics to the overall population within the watershed, and it wasn't very different. So we don't necessarily believe there was a bias in the way the survey was conducted. We think there likely was not, but something to consider. And the fact that they were interested in conservation can certainly impact the results of this study. So I just quickly want to acknowledge the Land Change Science Program, the USGS Core Science Systems Mission Area. If you're interested in learning more about this research, not necessarily within riparian areas, but within the larger watershed, we published last year in Air, Soil, and Water Research. And I just want to thank everyone involved with this project. So on that, that's all I've got. And if there are any questions, thank you.